Today we're going to be talking about question number 6 from the free response questions section on the 2015 AP Chemistry exam. But before we talk about the question, I want to explain how some of the concepts can relate to a real-life example. So in the question, it talks about how ionic compounds, or more specifically salts, dissolve in water and what happens when they dissolve in water. And in the formation of salt in real life, or sea salt, when the seawater evaporates, it leaves behind sodium cations and chlorine anions, which form together to make NaCl salt. So now, before we read the question, I want to talk about some of the main topics that are going to be seen throughout this question. The first being chemical bonding, or more specifically, ionic bonding. And ionic bonding is the force of attraction between the positive and negative ions in a compound. The second is atomic theory, or atomic radius, and atomic radius is just basically the measurement of the size of an atom. And lastly, reactions in basic solutions, and basic solutions are basically just solutions that have OH minus compounds. So now let's get into the question. A student learns that ionic compounds have significant covalent character when a cation has a polarizing effect on a large anion. As a result, the student hypothesizes that salts composed of small cations and large anions should have relatively low melting points. So what the first part of this question is saying, it's talking about these ionic compounds, which are in this table right here. And as we went over before, it's the bonds formed from the positive and negative attraction, and it's saying that they have significant covalent character. Now, covalent character is measured from the electronegativity differences between the two atoms, and the closer this number is to 0, the more covalent character the compound has. And this means that the ionic compound is going to show traits of a covalent compound, such as having a low melting point, and this is what the student hypothesizes. Now, part A asks to select 2 compounds from the table and explain how the data support the student's hypothesis. And before we can do this, we need to understand how atomic radius, how the trends work on a periodic table. So if we're looking at a periodic table, atomic radius increases as we go down the table. And this is because the atoms have more electron shells as we go down. And this is going to increase the radius of the atom. And then atomic radius also increases as we move left across the periodic table. And this is because atoms tend to have less protons and electrons, and therefore they're going to have less of an attraction, and the electrons are going to float further away from the center, making the atoms have a larger radius. So now we can go back and look at the question. So we have to identify 2 compounds in the table and one having smaller cations and larger anions, and this compound should have a lower melting point than one that has larger cations and or smaller anions. So if we look at the first 2 compounds, lithium iodide and potassium iodide, they have the same and we can go to the periodic table. Here we have lithium and potassium, and then iodide. And iodine is in both compounds, so we can kind of ignore that for now. But as we can see, lithium is higher than the potassium, and therefore lithium has a smaller atomic radius than potassium. And so we can say potassium has a greater radius than lithium. And according to the student's hypothesis, this means that the compound with lithium in it should have a smaller melting point than the compound with potassium in it. And if we look at the periodic table, that is correct, because 449 is less than 686. So our 2 compounds are lithium and potassium iodide, and we can say because lithium has a smaller radius than potassium, it should have a lower melting point, which it does. Now we can move on to part B. Identify a compound from the table that can be dissolved in water to produce a basic solution. Write the net ionic equation for the reaction that occurs to cause the solution to be basic. So a net ionic equation is a equation of a chemical reaction that includes just atoms that are involved in the reaction. So if we look at our table, we can see sodium fluoride. And now sodium fluoride, the sodium is soluble in water, so it will not be involved in the reaction. So we can start writing our reaction. You're going to have the fluorine minus anions, and you're going to add H2O, as it says in the question. And this is going to give you, since it says it's going to produce a basic solution, we know that there's going to be OH minus anions in the products. And you're also going to have your fluorine minus anions. And then lastly, we're going to have H plus cations from the H2O compound, and to balance out the equation. So now we can see that the H plus and the F minus, they're going to form a ionic compound between the attraction of the opposite forces. So our final reaction is going to look like F minus plus H2O yields OH minus plus hydrogen fluoride. And that about sums it up for the question. I just want to revisit some of the main points. Again, we talked about chemical bonding and ionic bonding, which helped us understand the student's hypothesis and helped us understand how to support his hypothesis in part A. We talked about atomic theory or atomic radius with the trends on the periodic table, and this also helped us answer part A. And then finally, the reactions in basic solutions, and this helped us answer part B, creating the net ionic equation that produced a basic solution. And I just want to again touch on how these concepts related to real life in the formation of salt, and I really want to emphasize how important these concepts are, and just like I said, it's more than just a question, because you're going to see it, because it happens every day in real life, just like the formation of sea salt. Thanks for watching.